Your 2.2 video notes, make sure you have already gotten this worksheet that says electric forces on it. We're going to start by reviewing magnetic forces from the last lessons, and then we'll fill in this chart.
Let's talk about magnets and magnetic forces. Magnets are these neat objects that are able to attract metals like iron. Magnets are used in all sorts of things, from holding paper on your refrigerator to computers to compasses. So magnets can be used to stick things together, point us in the right direction, and even lift things. And they do this through magnetic forces. If you've handled two magnets, you've felt magnetic forces, even when the magnets weren't touching each other. That's because magnetic forces are non-contact forces, which just means they can affect other objects they aren't even touching. Magnets will attract or repel each other, and this attraction or repulsion is a magnetic force. But magnetic forces don't affect everything the same way. Otherwise, a magnet would stick to you, not just a refrigerator. In this video, we're going to talk about the magnetic forces between two magnets. So why do magnets sometimes attract each other and other times repel each other? Well, this has to do with the orientation of the magnets. Orientation is really just a fancy word for how the magnets are positioned compared to one another. You see, it turns out that each magnet has a north and a south pole. But what does this have to do with attraction or repulsion? Well, as you may have heard, opposites attract. So, if you face the north pole of one magnet to the south pole of another magnet, guess what? They will be attracted to each other. But if you turn one of those magnets around so that you have two north poles facing each other, they will repel. And the same thing would happen if it was two south poles facing each other. So the direction of the magnetic force completely depends on the orientation of the magnets. Orientation, though, is just one thing that affects magnetic forces. The strength of magnetic forces depends on a couple of things. For one, distance. If you've ever held two magnets, you may have noticed that when you move them closer, they seem to almost jump together. Or if you try to push two like poles together, they get harder and harder to hold together the closer you get. This is because magnetic forces depend on distance. The closer the two magnets are together, the stronger the force between them. So, as the distance decreases, the force increases. But the farther away they are, the weaker the magnetic force is. So, distance increases, force decreases. The other big factor that affects how strong a magnetic force is, well, the magnets themselves. Some magnets are really weak, like a lot of refrigerator magnets. Others are so strong that even tiny ones can be almost impossible to pull apart. Some of these stronger magnets are even used to make high-speed trains levitate off the ground. And yes, this rectangle is supposed to be a train. While my drawing isn't amazing, the fact that magnetic forces can levitate a train is.
All right, let's see if you got these right. So here is what you should have written in for magnetic forces. So the force name is magnetic. The type of force is non-contact, meaning it doesn't have to touch to move, to pull or push. On the magnet, each magnet has two sides, a north side and a south side. These magnets can attract or repel. Now, it can attract by having opposite poles pushed together, or repel if the same pole is facing each other. And the strength of the magnetic force depends on distance and the magnet itself. Now let's move on to electric forces. So let's watch this video.
Have you ever taken a shirt out of a dryer and found a sock stuck to it? If you have, you might have noticed that once you pull the sock off, it was still attracted to the shirt, even when they weren't touching. What is even happening here? Well, it turns out there's an electric force between the shirt and the sock. Electric forces are a type of non-contact force, which means they can act on objects that aren't even touching. If you've ever noticed two balloons repelling each other, Or if you've ever noticed your hair sticking to something like a balloon or a sweater, that's what I'm talking about. But why is there an electric force between the shirt and the sock after they're taken out of the dryer? Well, it turns out that electric forces are caused by a property of matter called electric charge. Matter is made up of tiny particles that can have positive, negative, or neutral charge. Neutral just means that the electric charge is zero, not positive or negative. When you add up all these charges, most objects tend to have a net charge that is about neutral. Otherwise, we'd be attracted to all sorts of things, just like that sock. However, an object's charge can change. So, in the dryer, all that heat and movement allowed some negative charges from the shirt to move to the sock. Now, when you try to separate the two, they are both electrically charged, and there's an electric force between them. So, now that we know what causes an electric force, let's look at what affects its direction and strength. An electric force can attract or repel an object. But how do you know if an electric force will be attractive or repulsive? Well, as the saying goes, opposites attract. An object with a negative electric charge will be attracted to a positively charged object. If the second object is also negatively charged, well, the two objects will experience a repulsive force and be repelled from each other. So in order to have the sock and the shirt attracted to each other, they must have opposite net charges because they're experiencing an attractive electric force. What about the strength of that electric force? Strength will depend on a couple of factors. First, the charge of each object is proportional to the force. The stronger the charge is, the stronger the electric force. So, the greater the electric charge, the greater the electric force. Another factor, how far apart the objects are from each other. The electric force will weaken as the distance increases. So, the force decreases as our distance increases. As you move the sock away from the shirt, eventually the attraction between them is so weak that we don't even notice it. So, the next time you find yourself doing laundry and having to pull a sock off of a shirt, just remember, invisible electric forces are to blame.
All right, let's see how you did. All right, electric forces are also a non-contact force, meaning they do not have to touch in order to have a push or a pull on another object. In this case, we have two main charges, positive and negative, but you can also have a neutral charge. Just like magnetic forces, electric forces also attract and repel, and the same thing goes, opposite charges will attract and similar charges will repel. Strength depends on two things. One, distance, just like magnetic force, and then for the amount of charge, the more charges they have, the stronger the electric force. And if it has less amount of charge, the weaker the electric force.